Hey there guys, welcome to the video. My name is Pushpinder Gill, and in this video we're going to be talking about some standard integrals. Right, so some standard integration expressions which you should be knowing before you write any calculus exam. So standard integration expressions. So let's go ahead and get started, guys. Right. So now, till now, if you must have, if you watched the previous videos, you would know that the integration of a derivative of a function is actually equal to that function itself, right? So that means if I say, let's suppose if I have a function x squared, then the derivative of that function, so this is a function f of x, then the derivative of that function is actually equal to 2 times x, and again there's a constant added as well, right? So the derivative of that function is 2 times x. So that means if I integrate 2 times x dot dx, I would actually be getting x squared plus c. Something that we have clearly stated in our previous two videos. In this, what I'm going to do is I'm going to find out some standard differentiated functions, and then we're going to convert them back into their real functions. So the first standard function that I want to talk about is of integration of k dot dx, where k is actually a constant. Now what is going to be the integration of k dot dx? That is actually going to be equal to k into x plus c. Why? Because when you have, so this is going to be equal to k into 1 dot dx, and when do you get 1? When you have an x right here, right? Because it's again is going to be it's actually, you can consider it to be x raised to the power 0. Again you will have x raised to the power 0 plus 1 divided by 1 over 0 plus 1 plus c. So that means the integration of a constant dot dx is actually equal to kx plus c. Now the next type of this, what I'm going to do is the integration of x raised to the power n dot dx. This is something that we have already done, which is actually equal to 1 over n plus 1 into x raised to the power n plus 1 plus c, provided that n is not equal to negative 1. Because if n is equal to negative 1, this will turn out to be 0, and this whole integral will turn out to be indefinite, which is something that we do not want. Right, so that is something that we have done already. Now the third standard integral that I want to do with you guys is the value of 1 over x dot dx, right? So as you know that the dy over dx, sorry, the differentiation of log of x is actually equal to 1 over x, right? So that means this is going to be equal to log of x plus c, right? So that means this is what it's going to be. And again, since we can't take the negative of log numbers, that means this has to be positive. So we can't have a negative number here. That means this has to be positive. So this is the third standard expression that I want to talk about. The fourth one is about the integral of e raised to the power x dot dx. Now something that you already know that the differentiation of e raised to power x is actually equal to e raised to power x. So that means this is going to be simply going to be equal to e raised to power x plus c. So that's one integral which is important. Now the next is actually equal to the integral of a raised to the power x dot dx, right? So the integral of a raised to the power x dot dx, so that is actually going to be equal to 1 over log of a to the base e, right? So 1 over log of a to the base e into a raised to the power x plus c. Now the difference between the previous one and the next one is that over here it was 1 over log of e to the base e, which is why we did not consider it at all. Now this one over here is actually going to be 1 over log of a to the base e into a raised to power x plus c. Now again, if you see that if you differentiate this function over here, you will actually get this only. So that's actually very important, right? So I suppose you're understanding this point over here. To understand how did this differentiation come from here till here, you should watch the differentiation videos where we have found the differentiation of a raised to power x, right? So the next important integral that I want to discuss is the integral of sine x dot dx, right? Now as you know that the differentiation of the differentiation of cosine of x is actually equal to sine of x, right? And another thing, sorry, negative sine of x. So that means if I find out the differentiation of negative cosine of x, I will actually get sine of x, which means this is actually going to be equal to negative cosine of x plus c, right? So that means if I differentiate from here, I'll actually get this. If I integrate from here, I'll actually get this. So this is the sixth one here. The seventh one that I want to discuss is the integration of cosine of x dot dx, which is actually very easy. That is simply equal to sine of x plus c, because the differentiation of sine of x is actually equal to cosine of x, and the other way around is the integration. That's number 7. Number 8 is equal to the integration of secant square x dot dx. That is actually going to be equal to tangent x plus c. Again, if you watch the differentiation videos, in that you'll understand that the differentiation of tangent x is actually equal to secant square x. So that means the integration would be the other way around. So thank you very much for watching this video, guys. I suppose you've understood these important points. We're not going to stop. We're going to keep making more videos, and I suppose you'll be watching more of it. So this would be our website address to explore more about us, our Facebook page to give us your valuable like, and this is our email address to give us your valuable feedback. So thank you very much, guys, and I'll see you in the next one. Cheers.